Good morning, everyone. My name is Don Garnier. I'm a co-founder at a company called Blicon. As you can guess by our name, we're all about using Bluetooth. And today I will talk about how Bluetooth can be an amazing technology that you can leverage to build IoT connected products for businesses. So how businesses can leverage Bluetooth to get access to really high quality data from the physical world. And in my presentation, I will start with talking about some industries which have successfully applied Bluetooth in a range of use cases. And those really show what's possible so that when you build your own Bluetooth connected IoT device, you sort of know what the state of the art is out there. And then I'll look at a set of best practices that you can use to maximize your chance of success and get to market as quickly as possible. And those best practices are issued from the work we do at Blicon, but also my previous roles at ARM in the IoT division, where we saw quite a few projects using Bluetooth for IoT connectivity. And prior to that, when I was with a startup doing commissioning for IoT devices using Bluetooth. Finally, we'll conclude at the end of the presentation. So what are the sort of success stories which are out there? And there are like quite a lot, actually, for using Bluetooth technology in IoT. The first sort of vertical I'd like to highlight is the construction industry, and specifically some power tool manufacturers, which have been using Bluetooth successfully to help their customers have more efficient job sites and use their assets more efficiently. So the first thing they did is that they used a beacon type approach where they attached basically what were Bluetooth beacons to the tools which were on job site, which really helps their customers know where each tool is, which can be a huge waste of time if their workers don't have access to the right tools at the right time. But what I find really exciting is that they went a step beyond using classic beacons, and they started adding data collection capabilities to those devices, and then use Bluetooth as a way of sending that data back to a central location. For things like collecting safety data, is my tool being used in the range, the power range it's meant to be used, or is it at risk of overheating, things like that, that previously they had no idea about. So now they can tell their customers, or watch that drill, you probably wanted to send it out for maintenance because it was used in outside the safe range. They also know if those tools are used or not, and so they can send the right number of tools to their customers, because they had previously, they probably had too many tools for a job site or not enough. And also something which I also find really exciting is that now, and that sounds a bit stupid, but they know if those tools are running out of battery, and so they can tell their customers, change those batteries on those devices tonight, so that when your staff turn up next morning, they'll be ready to go and as efficient as possible. Another industry which maybe is a bit more obvious is the logistics industry, where also when you say logistics and Bluetooth, you probably think beacons, but a lot of companies went a step beyond and started using Bluetooth devices to track the condition of assets as they were working through a supply chain. And that's something that traditionally was done for just maybe very high value assets using cellular, but Bluetooth lets those companies do that at a much wider scale and enables a lot of new use cases. So they can track things like temperature or humidity or exposure to light, which for things like fresh food or pharma type assets can be critical. So if my my parcel of vaccines is left in a location where it's if it's exposed to a lot of light, left in the sun for an hour, then when it turns up to a next point where I have a Bluetooth gateway, then I'll know that I can't possibly use those vials safely, and I can go back to my supply chain provider and highlight that there was a failure, and that it can be fixed. That's a nice segue into the last vertical, which I'd like to highlight today, which is the healthcare industry, which is a very data-driven industry, but where getting high-quality data is a challenge, both for clinicians, who actually most often have no idea if a patient is adhering to a treatment that was offered to them. So if you have a medical device that is Bluetooth-enabled and collecting data about how much it's used by the patient, when it is used, is the patient respecting the right dosage, and things like that, when the patient walks back into the hospital and all that data is uploaded to the clinician's database, they can see, is the treatment not working because the patient is not using the device correctly, or not respecting the right dosage, or is it not working for other clinical related reasons. It can be also very useful for much earlier in the sort of life cycle of those medical devices, when they are being put through clinical trials, and that's a very, as you know, very data-driven exercise where you need some very high-quality data to support your clinical trial. Well, if you're using medical devices that are logging all sorts of actual numeric hard data, and those devices, when they come back to the hospital, whenever the patient who is part of the clinical trial has an interaction with the team who's running the trials, then you can establish much more confidently that your device is working or not working as expected to support that trial. So what are the sorts of best practices you can apply if you want to develop, to add those capabilities to your products? And I'll go through more technical specifics, and then at the end, things which are more about the organization of a project to make it successful. And when I say building Bluetooth connected IoT solutions, obviously the topic is huge. And something which is maybe a bit obvious is that to create a successful solution, you have to apply best practices from the Bluetooth world, and there's a lot of great content out there on how to build successful Bluetooth devices, but you also have to apply best practices on how to build successful IoT solutions. So I don't have half a day, so I'm focused on hopefully what's at the intersection, so the things which are sort of specific to Bluetooth IoT devices. So let's say you've added Bluetooth to your device, from which you're trying to send data back to your data warehouse or your data cloud. Well, you'll need to, do some impedance matching between the world of Bluetooth and the world of IP, I guess. So you'll need some forms of gateways or hotspots. Great news is that Bluetooth, as Damon said earlier, is so ubiquitous. It's in probably quite a lot of devices that you own already. So if you're trying to, develop something which is not going to require you to deploy new infrastructure, then you can leverage your park of mobile phones or laptops that already have Bluetooth embedded in them. Your constraints that you're going to have to work with the sort of limitations that the platforms give you, and usually that means interacting with your device at the GAT or LTCAP level. But maybe you'll also want to go a different route, which is building a custom gateway if you want to use some more specific Bluetooth features, more advanced Bluetooth features, which might not be exposed by your mobile or desktop platforms. In which case, the SIG provide you with an amazing tool that I use very regularly, which is that qualification workspace, where you can see, okay, for that specific OEM device or for that specific Bluetooth controller, what are the Bluetooth features which are actually supported? Because you don't want to get through a project and then discover that actually you made the wrong choice in terms of which controller you wanted to use. You will also have to think about protocols in a slightly different way to what you do if you are developing a personal Bluetooth device, where, let's say if I'm building a smartwatch, then the connection will probably be between my phone and the smartwatch, and a lot of the data will terminate into my phone. Like here we have more asymmetric situation where you have like your Bluetooth link going to your gateway, and then the gateway to the cloud, which is more based on IP. And those can have different throughput, and also your sort of gateway to cloud link will be might be like very fast or very slow depending on the conditions, and have high and low latency. So you'll need to think about, okay, how do I do flow control so I don't overwhelm my device if I'm sending too much data to it? How do I maximize throughput because I want to connect to a lot of those devices in a short amount of time? These kind of like considerations. Finally, if you're using mobile platforms, unlike a more consumer app, which will be in the foreground quite often, if you're using like mobile phones as more like background channel, you need to dive quite deep into the background modes that those operating systems give you. That's a very fast an example of an issue we came across with Android 13. Google rolled out a new Bluetooth stack, and basically after a certain number of connections, the stack would stop responding. So we sort of detected that through telemetry coming from the apps. But if you don't have this, you don't want to leave it to your customers telling you that your solution has stopped working. So if you have telemetry, if you have test farms, that can really help. Very briefly, also like some characterization we did on Android and iOS. You can see, so it's like for device advertising at 10 hertz rate. And then we measured like how long it took to establish a connection to get to a stage where we could actually send data. And there's quite a lot of variability in terms of the eagerness of the platforms to actually connect, and then how long it took to discover services and in the case of iOS, there's actually quite a lot of stuff which is happening in the background that you don't have control over. But yeah, like doing this kind of characterization can really help. The next area is more about topology that you'll need to think about, which is, once again, going to look a bit differently to what you do for a more consumer type device. And this will have some implications on your security model, because the trust relationship is not between, let's say, my smartphone and my car, or my smartphone and my watch. Now, in those use cases, the trust relationship really needs to be between your device and your cloud backend. And those hotspots in the middle, you don't necessarily trust them. So you need to look at how you're going to handle those kind of and many-to-many relationships between devices now being able to connect through hopefully a range of gateways or access points, and not only through a single trusted entity. So what does that mean? Yeah, you probably will have to start with building a threat model. But what's great about Bluetooth is that you can build application level security, which is specific to your use case. And the ubiquity of Bluetooth in this case is something that you need to be careful with, because if you have a sensitive application, because of Bluetooth everywhere, it's also very cheap to get access to tools to hack Bluetooth devices. And so I just came across DEF CON presentation. They were hacking Bluetooth locks with a Raspberry Pi and $200 worth of hardware. So yeah, really think about where in the chain someone could mess with your system, what are the mitigations you can put in place, and things like class attacks. So you don't want to have a case where someone hacks one of your devices and then all devices are vulnerable, or they can spoof traffic or sniff traffic from all of those devices. But also think about things the ability of people being able to generate a lot of spurious connections to your devices and draining your battery over a short amount of time. So The usual solutions that we've seen is that people end up doing something which looks a bit like transport layer security over Bluetooth and some kind of like public key infrastructure. That seems to be like the common pattern. And then you obviously have to choose if your device is a bit like like power constrained, like the right security cipher suites that will not drain your battery too quickly or overwhelm the memory of your device. The next topic I'd like to focus on is more once you've built your device, how will it get deployed in the field? And once again, that differs a little bit from what you would do for personal devices, because things like range and coverage will be things that will come up. But you might also have, a commissioning step where like you're setting up your device in the field and then you need to configure it a little bit, make sure it works. And I think the one common pitfall I've seen is that sometimes like the engineers working on creating those solutions forget that whoever is going to install the device is not an engineer, right? So working a little bit of user experience, like how do I make it simple for someone to set up my device is very valuable. It's time very well spent. Something which is great though is that those installers usually have a mobile phone or a tablet which has a mobile workforce management app with a list of jobs. And it does have Bluetooth technology, so you can really leverage that existing infrastructure to support the installation of your devices. The kind of like questions we usually get from installers is, okay, how do I know how many gateways I need to put in my deployment to make sure the system works? It's not an easy answer. There's no easy answer for that, so you'll need to come up with some, like rules that are easy to follow. And that's an example of some experiments we run with our neighbors at Cambridge Consultants, that we did like a characterization of a gateway, and then we built a mobile app which was using LiDAR to map out a space and would also measure the kind of like packet error rate coming from devices which were in range. All of that to build something that looked like that, some kind of coverage map around the space. So obviously green is like a very good ability to maintain a connection, and red like is I can't even connect to that device. So with tooling like this, you can really help people in the field to know, okay, in that case, maybe I need to put one gateway in that room and one in that other room, and really have like visual representation of your space. The next area I'd like to highlight, which is very critical for a successful deployment of a Bluetooth IoT solution, is the power management. And that can really be like, that's also something worth spending some time on. Because every time you change someone to how to change your batteries, it's going to cost you or your customer a lot of money. So you want to make sure that this is going to be a very predictable, thing, where like not some devices don't run out after 1 week and some others run out after a year, and your customers don't really know whether they can trust your solution. I guess the great news about this is that I guess Bluetooth is an amazing solution, amazing technology for building low power devices. It's really like it gives you a lot of dials, a lot of parameters that you can tweak to really make it fit your specific use case. I've listed those here. I won't go into the details, but those are the typical things you will look at in terms of maximizing your battery life. Something that's a bit overlooked sometimes is the overhead of establishing a connection. If you're like establishing a lot of connections and sending a little bit of data every time, then what will drain your battery is the initial connection setup phase, and not very much like the actually sending the data. So you might want to make sure that you don't that maybe you're buffering data for a bit longer before sending it out to maximize the use of your energy resource. This is an example of like some kind of modeling we did on the chart on the left-hand side. We compared in red a device profile where you're not advertising very often, and on the blue, the blue line is a device advertising a bit more often, and on the x-axis is how often those devices will connect to send data. And something that might sound a bit obvious, but is something that you need to be careful with is, if I don't connect very often, then obviously the advertising will dominate my power profile. But if my device connects very frequently, then it doesn't matter as much, and it's really the connection that will dominate the use of my power. Obviously, you need to test it, because modeling is great, but reality is it needs to be tested against real life. It's great because usually your Bluetooth device might have a battery gauge or something like that, and you can use Bluetooth to upload the actual data and make sure that your model is correct. The last topic I'd like to speak about is non-technical, but I've seen a lot of projects fail or get delayed because of that. It's really how you're going to set up the project, how you're going to architect the solution. And this is something which is really quite challenging for businesses to get right, because those projects involve different teams, which have very different ways of working. You need to involve hardware and firmware people on the device side, who have their own way of working, and you need to involve people from the cloud, backend, web world, and finally, in the middle, a team working on mobile or gateways, which might be more versed, in embedded Linux or iOS, Android, Windows. Different sets of cultures, different goals usually, or perceived importance for different parts of the project. So what you really want is make sure that you have some strong architecture lead who can keep those teams accountable and make sure that they can work well with each other. And usually that means defining interfaces, APIs very clearly and spending a lot of time on that. And once those are really clearly established, then each team can roll out their own work within their world. If you're not careful, your sort of mobile or gateway team, who is in the middle, of the in the architecture diagram, might end up being or becoming the de facto architects of your solution, which you probably don't want. So, to conclude, Bluetooth can be there's an amazing opportunity to build strong IoT solutions based on Bluetooth and give you the ability to collect real-world data from your products to understand how they behave, but also pass on a lot of value to your customers. Why is that the case? That the cost of adding Bluetooth to a device is quite often minimal. It's extremely low power. It doesn't require a lot of exercise or surface on your PCB. There's a very strong certification process and an ecosystem around Bluetooth from which you can get a lot of support. And finally, I think this is a very strong point, is, as Damon said earlier, Bluetooth is amazingly ubiquitous. It's everywhere. And the momentum behind the technology is very much there. And so it's only going to get better with roadmap items which will support building even better IoT connected products in the future. So things like faster data rates and things like that. So if you follow best practices, you have the opportunity to build some really amazing solutions, which can be secure, scalable, and reliable. Because at the end of the day, you need like all of that to deliver value to yourself or your customer. And in the era of AI, getting access to high quality data is very key. So that's my presentation. We have a booth in Hall 4 if you want to grab me there. I'll be around to talk about those topics. Thank you.